start by being a little grumpy on the recording because I have 4 wonderful people here at the session, all of whom deserve to get 100 A+ in the class. And I was thinking, since y'all had homework due, I'd have more people here. And then, not so many people, so I just actually checked to see how many people had turned in the homework so far. And only 4 or 5 people have turned in the homework so far. So I'm wondering if people are expecting to watch this recording to find out how to do the homework. And wouldn't it be funny if I just didn't record it and the people here got to learn how to do it and I didn't post this recording? Or maybe what I'm posting right now is a lie and I'm showing you the wrong way to do it. Anyway, so your homework has 2 problems on it. You've got a state minimization and an ASM chart. And so for state minimization, what you're trying to do is you have a state table, and you know from doing your project that sometimes you have a whole bunch of states, and it seems like there's got to be a better way to do this. And state minimization sees if you can get a finite state machine that's simpler, that does the same thing. So you're just trying to reduce the number of states. And so that's what state minimization is. And so we're going to work on an example of that. It's not hard. You just follow these steps and you'll be able to do it. But you do have to pay attention on following the steps because it's not really obvious what it is that you're doing. And so the first thing I want to make sure is that I'm not doing the same problem that you are assigned for homework, because that would be a real shame. So let's see. You were assigned this one, and I am intending to do this one, which is not the same, so that will work. Okay, so since I didn't have a worksheet, it's going to take the people here a little bit of time to copy this down. So I'm going to put this up here and I'll pause the recording while everybody copies it down. Okay, so while y'all are talking, copying, I am going to say one thing. A lot of times when I do this, people will ask, well, can I take, and you'll understand this after we do it, can I take a shortcut and kind of skip a step? And my answer is you can if you're careful, but I'm just not going to do it that way. I'm going to work it through, just step by step, not skipping any and not going for any shortcuts. And I'm not going to work any with doing a shortcut because I'm just going to show you this is a right way to get it. If you want to play around with saying, well, could I skip this step? We'll try it and see if you get the right answer. And a lot of times it does work, but I'm just going to do it in detail and not skip any steps. So what we're going to do to get this minimization is something called partitioning. And partitioning is when you take a set and you break it up into smaller sets. And our goal is that each set of states can actually be simplified and just be represented as one state. So it's like if I had a class that was full of all kinds of college students, but I just got one representative from first-year students, one from sophomores, one from juniors, and one from seniors, and those represented the whole state, the whole group, and as long as the same things happen to them and you get the same results, it should work. So your first partition, you'll call it P0, and P0 is going to be everything, all of the states. You just list them all. So P0 is going to be the set A, B, C, D, E, F, G, H, I, J, K, L, M, N, P. So that's P0. Yes.
Is P0 always like that?
P0 is always like that. It's just all of the states. And then P1 is also always done the same way. P1 is you look at the outputs and you group together the states that have exactly the same output. In our example here, we just have 0, 0, and 1, 0. But if we had some that had 1, 1 and some that had 0, 1, we would have 4 different partitions. But here we only have 2 partitions. We'll put all the states that have 0, 0 as an output, and then all of the states that have 1, 0 as an output. Yes?
Could you group it to where you just looked at Z2 and then just saw which ones had zeros and ones there, and then did Z1? Like instead of looking at them both, look at them separately?
No, that actually would not work. Because what needs to happen is that everything in the partition has to act the same way. And so if we don't have them all have the same output, they're not going to end up being the same. It's like in my example with the students, everybody who is a first-year student hasn't been at LSU for more than a year. But if I just said, okay, well, the other output is how many credits you have, and I just picked one person and said, okay, you have 7 credits, so everybody has 7 credits. Well, that doesn't work for everybody in the group, and then I can't treat them all the same. So they have to all be the same. So A, B, C, D, and F through J, F, G, H, I, J, and then L is through P, L, M, N, P. And your minimization is best if your final partitions are as big as possible. You want big partitions. And then my other partition are those that have 1, 0, which are E and K. If we get to a partition that only has 1 state in it, we never have to check it again, because we know that we're not going to be able to minimize that. It only has 1 state, and it can't get any smaller than that. And so if we get it down to 1 state, then we don't have to check anymore that partition. Okay, so this next part is where people start to get confused. And we're going to start by looking at, I can't remember, I call them 0 followers or 0 successors, and I don't remember what the book calls them or what your professor calls them. Do you remember to say 0 followers, 0 successors, anything like that sound familiar? Successors?
Yeah.
And it does not matter if you start with 0 first or 1 first, but I recommend that if you start with 0 first, then each iteration, each time you go through, you do 0, 1, 0, 1, 0, 1, 0, 1. So what that means is each time we have a partition, we're not done yet, but we're saying if we are done, we're saying everything in this group would act exactly the same, and everything in this group would act exactly the same. That would mean anything in here is interchangeable. They work exactly the same. We know that's not true, but if we were done, it would be true. So that means anything in here, if I have an input of 0, would have the same next state. Well, what do we mean by next state? Well, right now, this whole group is a state, and this whole group is a state. So I want to see, of the ones in this first group here, how many of them have, when W is 0, have their next state in this same group. So for instance, A's next state when W is 0 is D. B's next state is C. C's next state is A. D's next state is B. F's, can y'all read that? Yes. F's next state is L. G's next state is A. H's next state is F. I's next state is A. J's next state is N. L's next state is A. M's next state is G. N's next state is A. And P's next state is B. All right, so I want to look at these and see for which of these is the next state in our first group and for which of them is our next state in the second group. It's a lot easier to look for the second group. The second group only has E and K. Do any of these have a next state that's either E or K? No. All of them, their next state comes back to this same group. So that means I don't have to break this up anymore. It's going to be the same. A, B, C, D, F, G, H, I, J, L, M, N, P. Now I'm going to look at my other set. E's next state is A, and K's next state is also A. They both have their next state, they're both in the same set. So they can also stay together. If their next state is in the same set, then they stay together. So the 0 successors, nothing changed. So now we'll do the 1 successors. So I want to look at what the next state is when W is 1. So when W is 1, A goes to H, B goes to I, C goes to A, D goes to M, F goes to E. Why did I stop on that one and I didn't write down anything else? Why did I say, wait a minute, I got to pay attention to that one? It's in the other set. And then G goes to A, H goes to J, I goes to A, J goes to P, L goes to A, M goes to K, N goes to A, and P goes to F. So that means I need to break this up into A, B, C, D, G, H, I, J, L, N, P, and I need to put E and K together. I'm not E and K, I already knew about E and K, sorry. F and M. Okay, now I need to look at E and K. So when W is 1, E goes to A, and K goes to A. So those still get to stay together. As a matter of fact, I said I wasn't going to take any shortcuts, but I'm a really lazy person. And when I see a shortcut as obvious as this, I'm going to take that shortcut. What did I just discover about E and K? They're exactly the same. And not only are they exactly the same, it's like, exactly the same. There's no way they're ever going to do anything different. I'm just not at all concerned about them. I'm not going to check them anymore. They're going to stay together. So I know that's going to be a partition. Okay, so I've gone through the 0 successors and I've gone through the 1 successors. Did I make any changes? I did. If I made any changes, I have to go back and do them again. So now I'm going to go to my 0 successors and I want to look, and I remember that last time when W was 0, all of these states went to something in the same state. I still have mostly things in the same state, but I got F and M got pulled out. So if I don't want to check every one again, I can look and see if anybody is going to F or M, because that is going to be different. So when I look at W equals 0, I go down, I see an F. Did y'all see any other F's or M's in there? So the only new state I added in this last round was the state that has FM. So I'm just checking those. I mean, I could go back and check every single one again, but I know they're all going to go back to this same partition unless they go to F and M. So all I can pull out here is H. So, and I will. So I will group together A, B, C, D, G, I, J, L, N, P. And then I'll put H. Now I need to look at F and M and see where they go when W is 0. So F goes to L and M goes to G. Are L and G in the same set? Yes. And you can ask yourself, do I check this set or do I check this set? This is the part where I said if you want to be careful, you can kind of jump ahead and you can be looking at the next set ahead if you want to, and that it will work. But if you wanted to be safe, you just stick with your original set. So, but they still doesn't matter either way. They go to the same place. So that's F and M. And we already decided that we knew E and K were going to stick together, so we're not checking those. So those were the 0 successors. Now I need to check the 1 successors. So I'll look when W is 1. And I want to see, now I'm going to be looking for, to see if they're going, okay, I guess I lied when I said I wasn't going to take shortcuts. I can't help it. Really, the rules say I would just look here, and so I wouldn't check for H. But I know H is going to be another state, and so if I see something's going to H, I know it's not going to be the same as the others, so I'm going to pull it out. And so I'm looking at A, B, C, D, G, I, J, L, M, N, P, and I'm seeing when W equals 1, do any of them go to H or FM? I already know they don't go to EK because I already pulled those out. H or FM. And I see that A goes to H and D goes to M and P goes to F. Okay. So that means A is going to be in a set by itself. Why am I putting A in a set by itself? Because it goes to H, and where did the other two go to that I just found? F and M. Can I put them together? Can I put D and P together?
Yes.
Yes, because they're both going to FM. So I can put DP together. And then I'm left with B, C, G, I, J, L, N. And I have H. I don't have to check H because it's all by itself. Anything all by itself, it's not going to split up anymore. Now I do need to check F and M and see where they're going. F is going to E and M is going to K. Well, those are still the same, so those will be the same. So FM and EK. Okay, did we make any changes? We did. So officially we need to check again. but I know we actually already got them all because we kind of looked ahead with that H, but we can still check. We know A is going to be by itself. We know H is going to be by itself. We determined early on that E and K, we weren't going to worry about that anymore. Now let's look at D and P for zero successors. So D and P. So D goes to B and P goes to B. So are those okay? Can I keep D and P together for zero successors?
Yes.
Yes. D and P. Now I need to check B, C, G, I, J, L, N. B, C, G. So B goes to C. C goes to A. G goes to A. I goes to A. J goes to N. Is that in the same set? Yes. L goes to A. And N goes to A. Okay, so those all stay together. F and M, didn't they go to the same place? No, they didn't. F went to L and M went to G. Are they still in the same set? They are.
Could you explain that last state you did, the BCG, IJ?
This one? Okay, so I'm on the zero successors. And so I'm checking to see if those are going to be in the same group when I do zero successors. So I'm looking at when W equals 0 for B, C, G, I, J, L, and N. Now, of those that I just circled, I want to check to see, are any of those states not in the same group? So C is in this group, A is in, oh, A's not in that group. Oh, see, I told y'all I make mistakes on this. Yeah, so I messed that up. So I need to pull out all the ones that go to A. All right, so that was not correct because we pulled A out. So let me get that. A is in its own state now. Okay, so who went to A? C, G, I, L, N. Who did not go to A? B and J.
Did B and J go to the same one?
Do B and J go to the same one?
Like, did they have the same letter for the zero successor?
Okay, so now you're working like double ahead. And you can do that, but I'm going to wait and do that in the next step.
So
Yeah,
you just took it out because you simplified like half of them? You just
So,
had
so
this-
what I did was I found that currently these are all going to here, and these are going to here. And it is, or I'm sorry, I'm looking at the state above it, not the one that we're currently in. I'm saying so I'm working on this state and getting the zero successors. And from this state, these guys, C, G, I, L, N, they all went to A, and B and J stayed where they are. And then I'll have to check them again in a minute. Okay, so those were the zero successors. Now I'll check the one successors. I don't have to check the states that are just singletons. I don't have to check EK because I gave up on them early. Okay, D and P. D goes to M and P goes to F. Those are still the same. F and M are still in the same. D and P.
So shouldn't those be good? Like, for payment?
unless F and M change. That's the thing, because that's
Every
why
change you
if you
check.
make a change, you have to do another round. C, G, I, L, and N. C, G, I, L, and N. Okay, so C goes to A, C, G, I, L, N. They're all going to A. B and J. B is going to I. J is going to P. Those are different, aren't they? Yep. So these have to split up. F and M. F goes to E and M goes to K. Yeah, those are probably going to be the same because we know E and K aren't changing. Let's look at F and M and see if we can stop checking on them. So F and M, E and K, that's fine. And the zero successors were L and G. Oh, I don't know. That might not be it. Okay, so we'll still have to check them again. All right, so now I have A, I don't have to check again. H, I don't have to check again. B, I don't have to check again. J, I don't have to check again. E, K, we said was good. So now I'm going back to zero successors again. D and P. D's going to B and P's going to B. That's fine. These guys, I remember they all went to A. F and M. F went to L and M went to G. Are L and G in the same set? They are. Okay. I don't think I made any changes there. And now the one successors, I don't have to check A, H, B, J, E, K. D and P. D goes to M, P goes to F, that's fine. C, G, I, L, N, those all went to A, I remember that.
On the second one too.
Yeah, they did. They all had AA. And F and M, I think those were the same too. I think that's all you asked, F, because they were E and K, yeah. Okay, so now I went through a round of zeros and ones without making any change, so I'm done. Let's see if I finally got this one right. I've done this one like every year, and I make mistakes with it, including the year that like I wrote up the solutions for it, which was bad. Let's see if I got it this time. Oh, it doesn't look like I did. No, AB, that's fine. CGILN, CGILN, DP, EK, FM, H and J. Got it. Okay, now, I could have, and I called this P0 and P1, and then I forgot to continue numbering them. P2, P3, P4, P5, P6, P7, P8, P9, P8 equals P9. We're done. Okay, so that is how you do a state minimization. Do y'all want to do, I'm going to give y'all one to do on your own that's quick and easy. Okay, so this one is going to be so you just have 3 states. Now, it's slightly different because it's a Mealy machine, but you still are going to work it the same way by looking at both outputs together. So why don't y'all try this one, and I'll pause it while y'all work on it, and then we'll see. To make your minimized state table, you have your minimized states. Then you pick a representative from each group. So I'll have A, B, so A for this one, B for this one. I'll choose C for that one. I'll choose D for this one. You don't, I mean, it's obvious what I'm doing is I'm getting the smaller ones. You don't have to. You can choose whichever one you want. F from that one, and H from that one, and J from that one. So I have 1, 2, 3, 4, 5, 6, 7, 8 states as opposed to however many we had up here. So my new state table, I have A, B, C, D, E, F, H, J. And then I'll have W equals 0, W equals 1, and output. So now let's see. A went to DH originally. A went to DH. D is good. That's one of my states here, and H is fine. So that's fine. And that was a 0, 0 was my output. B went to CI. Okay, so C is fine, because that's one of my new states. I can't use I, though, because that's not one of my states. So I go back and I see which group I was in. I is in group C. And so that becomes C, and my output was 0, 0. C went to AA. And the output was 0, 0, and that's fine. A is one of my states. D went to B and M. Okay, B's fine, I've got that. M, I called the group that has M in it, I called that F. So this will be F, and the output was 0, 0. E went to AA, and its output was 1, 0. F went to LE. L is not one of my reduced states, so I find out which set it was. It's in set C. It's in the set I called C. And the output for F was 0, 0. H went to FJ. So what should I put? Can I keep F? What's that? For H. So H originally went to F and J. Can I keep F?
Yeah.
And I can keep J. And H was 0, 0. And J went to N and P. I can't keep those, so let's see. What set was N in?
C.
N was in C, all right. And what set was P in?
D.
So that'll be C and D. And was its output 0, 1 or
0,
0,
0.
0? Okay. And so that is the minimized state table. Okay, so now y'all are going to do the same thing with this little bitty state table right here. Going to minimize that. So remember, your P0 is always going to be all of your states, which are C, D, and E.
I don't think we even learned this
I
in class.
doubt it.
She did go over at least a minimization. I don't know about
She doesn't usually, this topic only gets to, the people only get to it, the professors, I'd say 1 out of every 4 semesters. And I don't think she's ever had it before, so I'm surprised it's on the homework.
Yeah, I don't think we've ever dealt with an ASM chart before.
Yeah.
Okay, well, let's,
And we briefly went over state minimization. We had one class on it.
I would expect you might have state minimization on the exam. I doubt you'll have ASM. Let's just talk about. All right, so with an ASM chart, the way it works is you have a box for each state, and you have diamonds are inputs where you make a decision. If you have an output of 1, you put a circle. If you have an output of 0, you don't put anything. So in this particular one, we only have 2 states. And the reset goes with state G. And then once you're in a state, you'll check the value of a variable. And if you do different things, if you don't do different things for that variable, you don't put it in your ASM chart. But if you do different things, you put it in your ASM chart. So if your first variable is 0, do you do the same thing every time? And the answer is no. You will go back to state G every time. But if the second variable is 1, you get an output. And if the second variable is 0, you don't get an output. So we do have to check the second variable here. I'll just call it Y. I do have to label these to indicate how they're different somehow. And then if I get a 0 here, so I'll put my outputs on this are going in this direction, 0 and 1. If I get a 0, I go back to state G. If I get a 1, I get an output, and let's just say that variable name, oh, it's S, sorry, these were A and B and S. There they are labeled. This is A, B, and S. So I get an output of 1, and then I go back to state G.
Why does 0, 0 go to G?
Because 0, 0 is right here.
Oh, okay, but it doesn't have.
So 0, 0 means I get a 0 here, and then I get a 0 on B. And if I get a 0 on A and a 1 on B, I go to S and then back to G. If I get a 1 on A, then I check my B. And if I get a 0 on B, I get my output of S. And I go to G. If I get a 1, I get an output of 0. So an output of 0, I don't have to do anything. I don't have to put a circle. But I go to my next state. And that state is H. And then from H, I first check A. And if A is 0, do I do different things? Yeah, I do. I do have to check B.
So for 0, if they were both, let's just say they were both 0 for the output, you wouldn't have to check B.
If they were both 0 and they went to the same state.
What if they had a different output? Like the one had a 1 and 1 0?
That's what we saw up here with B, and I had to separate them. Oh, 0, that was 1. Okay, so we had 0, 0 from H has an output of 1 and goes to G. So it'll have an output, and then it goes to G. I can just like join into this path that's going to G. If I had a 0, 1, I don't have an output, and I go back to H. If I get a 1, 1, I have an output of 1. And I go back to H. And if I have a 1, 0, oh wait, I messed that up. I need to put a B in there. Because I did different things based on different B's.
Even if you could not put a B, is it still fine if you do? Like, is it wrong if you put a B?
I don't think so.
Okay.
It's like the idea, is your code as concise as possible? No. Does it work? Yeah. I mean, as long as it's correct. So I had a 1, 0, a 1, 0, output of 0 back to H. 1, 1, output of 1 and back to H. So yeah, those of you watching this recording, I accidentally forgot, truly and truly did forget part of the recording, but I think I covered everything again. Yeah. All right. Any questions?
What is the carry-in 0 and 1? Like, we didn't use that, I don't think.
You know, so she usually does not do this particular example. This is an example of something called a serial adder. And it's a finite machine that does something, but she usually doesn't do that, so you don't need to worry about what this is saying. It's describing the different states. It doesn't actually become part of the ASM chart or the finite state machine. So it's a description of what it does. Sometimes in some sections they cover this particular thing, but she's never covered it before, and I doubt she would try to do ASM charts, the serial adder, and a final exam review all in one day. So, yeah.
I think we did do the serial adder.
Oh, you did? Okay, well then let me explain this real quick. It'll be real quick. So, what this is saying is if you have, if you're adding two numbers, so let's say I'm adding 1 and 0. If I add 1 and 0, I'd get a 1 if my carry-in is 0. And if I add 1 and 0, I get a 0 and my carry-out is 1 if my carry-in was 1. So carry-in is what you carried before, and a carry-out is what you would carry out. And so what this is saying, state G is your carry-in was 0, and state H is your carry-in was 1. So if I take two numbers, 0 plus 0, and I add them together, if my carry-in is 0, I get an output of 0. If my carry-in is 1, I get an output of 1. And so state G is saying your carry-in is 0. So it should get me 0 plus 0 has a carry out of 0. And that means, and the sum is 0. So the second number here is the sum. And so it goes, and it goes back to itself.
Is the output, is it basically just like the output that you get is like what it equals to at the bottom, and then, like, is that how it got this, is it just explaining how it got 0 and 1 basically, with the carry in for G and H?
Yes,
Okay.
yes.
So you don't really need it for the ASM?
No, you don't need it at all for the ASM chart.
Okay.
Yeah,
Well, that makes sense.
yeah, yeah.
It's just adding A and B together, essentially.
Yeah, it's adding A and B together. And you're going to the next state based on, like,
If it has a carry in or a carry in of 1 on the H side, right?
right. I'm trying to see, we don't, so if I had a carry in of 1, and I add together 0 and 0, the answer would be 1, and your carry in would be 0, so you go back to G. If I added a 0 and 1 and my carry in was 1, that means I'm on my H side. That means my sum is 0, but my carry out is 1. So I would stay here, and that's this top one. So this is just describing how the serial adder works.
How would there be like a question on that? Would there be a question?
Yeah, let me think of what, hold on, there. So when there has been a question on it, it was interpreting some Verilog. And showing, no, it's showing this, showing the states and sequences like what we were just doing. And then here's the Verilog on it. Except all of that I did here, I did this to help with a lab, not because I knew about a test question that had been on it. So, but I don't know what he puts on, or she puts on the final exam, because I don't ever see those. I see the other tests, but it's just my best guess on the final exam. So I don't know. Let's
She
see.
didn't show you the final at all?
Is it practice more?
She usually tells me what kind of questions there's going to be and shares with me, and then I share with y'all what she shares with me. It's not like a secret. It's not doing anything nefarious. So, but I'll let y'all know at the review session if there's something that I think y'all need to know.
Okay, thank you.
Oh, except for those of you who aren't here, I'm just going to tell these 4. Those of you who aren't here, I'm not going to tell you. Except for you, and you know who I'm talking about. I'll tell you.